All right, get ready, because today we're going deep on something pretty crazy. What if AI could not only diagnose diseases better than doctors, but could actually, like, unlock the secrets of the universe?
Yeah, it's like this intersection of intelligence and physics. AI is becoming this powerful tool for scientific discovery.
Right, and the really exciting part is this idea of intelligible intelligence.
Hmm.
It's not just about black boxes,
Yeah.
spitting out answers, but AI that we can actually understand. AI that helps us grasp the why behind the what.
Absolutely. That's what makes this deep dive so interesting. We've got all these research papers and articles that explore how AI is being used to rediscover known physics and potentially even uncover new laws of the universe.
Okay, I'm hooked already. Where do we even begin?
Well, one of the most impressive examples is the system called AI Fineman, which uses something called symbolic regression to rediscover famous physics equations.
Wait, you're telling me AI can find equations like EMC on its own? That's the one that basically says you can convert a tiny bit of matter into a massive amount of energy, right?
Yeah.
Like the principle behind nuclear power.
Exactly. And what's even more remarkable is that AI Feynman often outperforms previous human attempts at similar tasks. It's like giving the AI a bunch of data points and then watching it piece together the underlying equation, like a superpowered detective solving a cosmic puzzle.
So how does it actually do that? Is it just like brute force, crunching numbers until it finds something that fits?
It's actually more elegant than that. AI Feynman uses a technique called symbolic regression, which is essentially a search through the space of possible equations, trying to find the one that best describes the data.
Okay, but there are an infinite number of possible equations, right? So how does it narrow down the search?
That's where the power of deep learning comes in. These models, they have this amazing ability to adjust their parameters smoothly and fine-tune their search based on the feedback they get from the data. It's called differentiability, and it's what allows them to navigate that vast space of possibilities and zero in on the most likely solutions.
So it's not just random guessing, it's a guided search using the power of deep learning to kind of home in on the right answer.
Precisely. And AI Feynman's success in rediscovering equations from Feynman's lectures is a testament to how powerful this approach can be. It's like the AI is retracing the footsteps of one of the greatest physicists of all time, using data to rediscover the fundamental laws of the universe.
That's pretty mind-blowing. But you mentioned that there's more to this story than just rediscovering known physics. There's this whole other level where AI might actually help us uncover new laws, right?
Yeah, absolutely. That's where things get even more interesting. We've got these other techniques, like progression and AI Poincaré. They go beyond just finding equations. They're designed to discover the underlying structure of physical systems, the hidden patterns and symmetries that might point to entirely new physics.
Okay, I'm definitely going to need you to unpack those. Let's start with progression. What is that all about?
Imagine you're trying to describe the motion of a double pendulum, that thing that swings around in this
Yeah.
seemingly chaotic way.
Yeah, the one that looks like it's about to fly off in all directions at once.
Exactly. Now, if you try to describe its motion using standard coordinates like x and y positions, the equations get really messy and complicated. It's like trying to map a hurricane with street signs.
Okay, yeah, I can see how that would be a problem.
But progression can actually discover a completely different set of coordinates, a different point of view, from which the equations become incredibly simple and elegant. It's like finding the language that the pendulum speaks, the natural way to describe its motion.
So it's not just about finding the answer. It's about finding the right way to even ask the question.
Precisely. And what's even more amazing is that progression has been shown to rediscover the concept of inertial frames in physics.
Okay, now you're going to have to remind me what inertial frames are. It's been a while since my high school physics class.
Think of it this way. Imagine you're on a train moving at a constant speed. Inside the train, the laws of physics seem to work normally. You can toss a ball up and it lands back in your hand, but to someone standing outside on the platform, the ball's motion looks much more complicated because it's also moving horizontally with the train. The inertial frame is basically the point of view from which the laws of physics appear simplest.
So it's like finding that special vantage point where everything just clicks into place.
Exactly. And the fact that progression can rediscover these fundamental concepts from data is a huge indication of its potential to uncover deeper truths about the universe.
This is all so fascinating, but we still have AI Poincaré to explore. And I'm dying to know what that's all about.
That's where we'll pick up in our next segment. AI Poincaré is all about finding the hidden symmetries. in physical systems. And that's where things get really mind-blowing. So we've been talking about these incredible AI systems like AI Feynman and progression, but there's another player in this game of intelligence physics we need to discuss.
Right. You mentioned something called AI Poincaré, the one that's all about finding hidden symmetries. That sounds pretty deep.
It is. It really gets to the heart of how our universe works. Think about it. The laws of physics are the same whether you're here on the other side of the world or even in a galaxy far, far away.
Yeah, that's one of the things that's always blown my mind about physics. The same rules apply everywhere.
Exactly. That's spatial symmetry. And they're also the same today as they were yesterday. That's time symmetry. These symmetries are baked into the very fabric of reality.
Okay, so where does AI Poincaré fit into all of this?
Well, AI Poincaré is like a cosmic detective that can uncover those hidden symmetries by looking at data from physical systems. Remember how we talked about conserved quantities like energy and momentum?
Yeah, those are kind of a big deal in physics, right?
Absolutely. They're like the bedrock of our understanding of how the universe works. Energy can't be created or destroyed, only transformed from one form to another. And momentum, well, that's all about how objects move and interact.
So AI Poincaré can somehow find these conserved quantities just by analyzing data.
Exactly. Imagine you're watching a simulation of that chaotic double pendulum we talked about earlier. AI Poincaré can analyze the data from this simulation, and even though the pendulums are swinging all over the place, it can pinpoint the total energy of the system.
And that total energy remains constant, even though the motion is so chaotic.
You got it. It's like seeing through the chaos to find the underlying order, the hidden patterns that govern the system's behavior.
That's pretty amazing. But you said AI Poincaré can also find symmetries. How does it do that?
Well, there's this incredibly elegant theorem in physics called Noether's theorem. It basically says that for every symmetry in a physical system, there's a corresponding conserved quantity.
Okay, I'm going to need you to break that down a bit for me. What exactly do you mean by symmetries in this context?
Imagine you have a perfectly round ball. No matter how you rotate it, it looks the same, right?
Yeah, because it's symmetrical.
Exactly. That's rotational symmetry. And because of that symmetry, the ball's angular momentum, which is a measure of its spin, is conserved.
So in a way, symmetries are like the rules of the game that determine what can and cannot change.
That's a great way to think about it. And AI Poincaré has the potential to uncover new conserved quantities, which then point to hidden symmetries we haven't even thought of.
So could AI Poincaré actually lead us to brand new physics? Something we haven't discovered yet?
That's the million-dollar question, isn't it? And honestly, no one knows for sure. But the possibilities are incredibly tantalizing.
This is all so mind-blowing. It feels like we're standing on the edge of a whole new understanding of the universe.
It really does. And what makes AI Poincaré even more powerful is its ability to measure complexity.
Complexity? How do you even measure something like that?
Well, in this context, complexity relates to how much information you need to describe a system. Remember how progression found those special coordinates? That made the double pendulum's motion easier to describe.
Yeah, like it found a simpler, more elegant way to express the same thing.
Exactly. AI Poincaré is kind of similar. It seeks the simplest possible description of a physical system, and that simplicity often points to deeper underlying symmetries.
So AI Poincaré is all about cutting through the noise and finding the most elegant representation of the underlying physics.
You got it. And the really cool thing is, AI Poincaré is not limited to just physics. These techniques can be applied to any field, where finding hidden patterns and relationships is key.
So we can use these tools to analyze everything, from financial markets to climate data to the human brain.
Exactly. The possibilities are incredibly vast. But before we get too carried away, it's crucial to remember the core theme here: intelligible intelligence.
Right. We want AI that we can understand and trust, not just black boxes that spit out answers we can't make sense of.
Yeah. Absolutely. These AI systems are not about replacing human understanding. They're about enhancing it, giving us new tools to explore the universe and ourselves in ways we never could before.
Okay, so we've talked about AI Feynman rediscovering famous equations, progression, finding the language of physical systems, and AI Poincaré uncovering hidden symmetries and conserved quantities. Where do we go from here?
That's a great question. And that's where we'll pick up in our next segment. We'll explore the challenges and opportunities that lie ahead in this quest to use AI to unlock the deepest secrets of the universe.
So we've explored some pretty mind-blowing concepts about how AI is being used to rediscover known physics And potentially even uncover new laws of the universe.
Yeah, we talked about AI Feynman, progression, AI Poincaré. It's like we're witnessing the birth of a whole new field, intelligence physics.
It really does feel that way. But let's get real for a second. What are the actual challenges in using AI to discover new physics? I mean, it can't all be smooth sailing, right?
You're absolutely right. There are some major hurdles we need to overcome. One of the biggest is the issue of complexity.
Right. We talked about how AI Poincaré can measure complexity.
Hmm.
But how does that relate to finding new physics?
Well, imagine you have two competing theories that both seem to fit the data. How do you decide which one is more likely to be correct? One way is to look at their complexity.
Right. It's like Occam's razor.
Yeah.
The simplest explanation is usually the best.
Exactly. But the problem is that defining and measuring complexity can be incredibly tricky, especially when dealing with systems that are, well, complex.
So we need to develop better ways to quantify complexity if we want AI to help us find the most elegant and likely explanations for the universe.
Precisely. And that's just one challenge. Another is the issue of data bias. AI is only as good as the data it's trained on.
Right. It's like the old saying, garbage in, garbage out. If we're feeding the AI bad data, we're going to get bad results.
Exactly. So we need to be extremely careful about ensuring the quality and diversity of the data we use. We need to make sure it's representative of the phenomena we're trying to understand, and that it's free from any systematic errors or biases.
Makes sense. What about the interpretability of AI's findings? Even if an AI discovers a groundbreaking new equation, we need to be able to understand what it means.
Absolutely. It's not enough for AI to just spit out an answer. We need to be able to translate it into a language that human physicists can comprehend and test.
So it's not just about the AI making the discovery, it's about us being able to understand and verify it.
That's exactly right, and that requires a deep collaboration between computer scientists, physicists, and mathematicians. We need to develop new tools and techniques for visualizing and interpreting the output of these AI systems, making the complex more comprehensible.
Okay, so it sounds like there's a lot of work to be done, but the potential rewards are huge.
They are. Imagine a future where AI helps us unlock the secrets of dark matter, dark energy, the very fabric of space and time. The possibilities are truly mind-boggling.
This has been an incredible deep dive. We've explored the power of intelligible intelligence, the potential for AI to revolutionize physics, and the profound implications for humanity's quest to understand the universe.
It's been a fascinating journey. And I think one thing is clear. We're on the cusp of a new era of scientific discovery, one where AI will play an increasingly important role.
And who knows, maybe someday we'll look back on this conversation as the moment when we first glimpsed the incredible possibilities that lie ahead.
I like that thought. It's been a pleasure exploring these ideas with you.
Thanks for joining us on this deep dive. And until next time, keep questioning, keep exploring, and never stop wondering about the mysteries of the universe.